Hi, I'm Zoe Kuhn, and this problem is from Chapter 19 on electrochemistry. Specifically, the problem will involve balancing redox reactions in acidic conditions. The problem we will be addressing is MnO4- plus aluminum solid being reduced to manganese 2 plus aluminum 3 plus. The major goals when solving this problem are to balance the redox reactions in an acidic environment, meaning that there will be H plus ions in the final reaction. To do this, the problem will be broken down into 7 smaller steps, starting with breaking the reaction into 2 half reactions, identifying oxidation numbers throughout the steps, identifying which reaction is being oxidized and which is being reduced, and in turn identifying the cathode and anode of the problem. Step 1 is writing the full unbalanced equation and finding the oxidation numbers of each element in the reaction. Starting with aluminum solid, we know that this has an oxidation number of 0 because this is its natural state and no charge is indicated with a plus or minus sign. Manganese 2 plus and aluminum 3 plus are also easy to determine because the oxidation numbers are given. These are 2 plus and 3 plus respectively. The MnO4- is a little bit more difficult. We know that the oxygen always has an oxidation number of 2-, and we know that the entire compound has to have a -1 charge. Thus, we set up the equation x plus -2 times 4, because there are 4 oxygen atoms, equals -1. After quick algebra to solve for x, we can determine that the oxidation number of manganese is +7. Now that we have the oxidation numbers of all the elements in this reaction, we can separate the total reaction into 2 half reactions. We take the aluminum ions and pull those apart to make the first half reaction, just aluminum solid to aluminum 3 plus. Since this reaction is going from 0 oxidation number to +3 oxidation number, it is being oxidized. Since it is being oxidized, we automatically know that this is the anode of the problem. We then do the same thing for the manganese ion, but this time, since we are going from a +7 charge on the manganese to a +2 charge, we know that this is being reduced. This automatically makes this the cathode as well. Once we have separated the half reactions, we can begin step 3, which requires us to balance the number of atoms. We balance the atoms and do not pay any attention to the charges on the ions just yet. Since the first reaction is technically just 1 aluminum atom to 1 aluminum atom in aqueous solution, it is already balanced 1 to 1. The second reaction requires us to balance the oxygen atoms in the product side. Since oxygen is in the reactant side with the manganese, but there's no oxygen in the product side, we had to add 4 oxygen atoms to the product side. However, since this reaction is an acidic environment, we couldn't just balance the oxygens by themselves and instead needed to use water atoms. To balance the oxygen, we used 4 water molecules to the product side. However, this then produced 8 hydrogen atoms to the product side that are not on the reactant side. Now we have to add 8 hydrogen atoms to the reactant side. Because this is an acidic condition, adding hydrogen atoms to it is a good thing and will not affect the solution overall very much. Our new balanced equations are aluminum solid being oxidized to aluminum 3 plus and MnO4- plus 8 hydrogen atoms being reduced to manganese 2 plus and 4 water atoms. Step 4 is balancing the charges by adding electrons. Look at the first reaction, we see that there's a 0 charge on the reactant side and a +3 charge on the product side. To balance this, we have to add 3 negative electrons to the product side, making the new equation aluminum solid being oxidized to aluminum 3 plus 3 electrons. For the second reaction, we know that the MnO4- compound has a -1 charge and the 8 hydrogen atoms have a +8 charge, meaning that the reactants together have a +7 charge. The products, on the other hand, have a +2 charge from the manganese ion and a net 0 charge from the water molecules, because water is always 0. Thus, we have a +7 on one side and a +2 on the other. We have to add 5 negative electrons to the reactant side so that -5 plus +7 equals 2, which is equal to the charge of the products. Now we have 3 electrons on the product side in the first reaction and 5 electrons on the reactant side of the second equation. Step 5 involves multiplying the half reactions in order to get an equal number of electrons. Since the first reaction has 3 electrons and the second reaction has 5 electrons, and the closest common denominator is 15, we have to multiply the entire first reaction by 5 and the entire second reaction by 3. Make sure to multiply every species involved in the reaction. This is the result of multiplying 5 and 3 respectively on both sides. There are now 15 electrons for both reactions on opposite sides of the arrow so that they can be canceled out. You can also see that everything in the reaction was multiplied by 5 or 3. In the second to last step, cancel all similar terms. The only similar term in both reactions that are on opposite sides of the arrow are the 15 electrons, so those get canceled out. Everything else is kept. In the final step, you combine everything from the 2 half reactions to get one final reaction. The final reaction is 3 MnO4- plus 24 hydrogen atoms plus 5 aluminum ions redoxing to 3 manganese ions plus 12 water molecules plus 5 aluminum 3 plus ions, with the manganese being reduced and the aluminum being oxidized. Thank you, and I hope this helps.